Alright, welcome back. In this lecture I'm going to show you how to do a slightly more organic modeling style using Soft Select, Lattice, Nonlinear Deformers, and Sculpture Paint. So these are actually really fun tools to use, but they are less precise, and so we have to be careful about how we approach modeling things. So I'm going to start out by demonstrating the soft select just because it's a very easy one, very fun one to experiment with. Let's go ahead and create a polygon primitive plane, and we want to make sure, I'm just going to enlarge this actually to the size of the grid. We want to make sure that it has many divisions running through the center of it. So I'm just going to turn up this number to its maximum, which is 50. And we're going to need that polygon density because smooth curving forms require many faces to get that effect across, because if you have too many faces, then we're going to easily see the faceting of the faces as they move, and it won't appear to be smooth. Okay, so I'm going to turn this to smooth shade view, and to access soft select, all we have to do is hit the letter B, but let's make a selection first. So I'm going to grab a vertex and just click a single vertex on our grid and move it. And so this is a normal movement method. There's one vertex, and if I dragged a selection, these are several vertices, but that is not a very convincing slope. When I drag these, none of the surrounding information is affected in any way, and that's good for hard surface modeling and mechanical things, but it's not very good for organic things or flowing things. So I'm going to put that back down, grab a single vertex, and let's go ahead and open up the tool settings panel. The tool settings panel, when you don't have a specific tool selection, just has movement options, joint orient options down here, I suppose. But if you scroll down in this pane, you'll come to the soft selection region, and if you click that button on, you may or may not see a reaction here, which looks a little bit like that, sort of a heat map of influence. Now, if I hit the reset button here, it looks like the default is 5, so hopefully if yours is on defaults, you should get a nice region like that. But we can change this fall off radius on the fly without even accessing this menu. First of all, you can turn on and off soft select by tapping the B key, B as in boy. Okay, there we go. And if you want to affect the radius, all you have to do is hold down the B key and then left click and drag to the right for bigger and the left for smaller. So there's our interactive heat map. So single clicking anywhere on a single vertex on this map, we can get this nice heat fall off, and then if I drag this upward, you can see that it is affecting the neighboring vertices less and less and less and less until it finally falls off entirely back to our straight flat grid. And so you can see a rather nice organic kind of look there is achieved with this soft select. So this can be a way for you to make like some terrain, you know, size this brush down and up and grab a few, maybe even grab a line of vertices. So I'll grab a few here, and you can make like a little hill or whatever. Okay, so this is a nice way to affect things in a smooth, not really as specific and unforgiving way. And if I make this large enough, I can affect the entire region, squishing and pushing and pulling the entire region here, which is, you know, pretty satisfying to do. It's worth noting that there are some specific settings on this soft selection which we can use to our advantage. This little chart here, this fall off curve, is a representative graph of how much influence you have near the selection point and then far away from the selection point over here. So right now it's set to a standard bell curve, which is this first curve preset button that you can click here. But we can change it to something maybe a little bit more linear. So for instance, with that selected, if I click, I'm going to make it smaller, and drag, I end up getting a point on either end of this transformation range. So I'll get a spike here, and I'll get a sudden termination of the transform on the bottom. Let me do that over in this flat area. It'll be a little bit easier to see. It should just look like a cone at that point. Okay. We can use a whole bunch of these different settings. So let's see, this one is a plateau. So we will affect the surrounding vertexes equally, and then there will be a sudden drop off around that selection. So you see there, all of these vertexes are being pulled up the same amount because this is all 100% until it finally drops off. And there's weird ones too, like this stair step one is a little bit bizarre. I'm not really sure what to use this for practically, but you know, there you go. Kind of a layer cake or a mountainous kind of look to it, which is pretty neat. Okay, we can always customize this graph as well just by dragging these points around, and you can delete them by clicking these little boxes underneath here. So in this case, I've just made a stair step kind of formation with one small stair, one big stair, and one low stair. Let me turn that one all the way off. So now if I select a region, I'm going to get a similar effect with less steps, right? And you can do other things too. So let me delete a couple of these. Boom, boom, boom. That one, that one. So I've got this point which I can move around. The interpolation setting here can be changed to none, linear, smooth, or spline. If I set it to spline, let's see. If I'll just click it in a second spot and turn it to spline. There we go. You can see it gets a nice smooth kind of interpretation. So I can make kind of a sudden spike. So a spike which falls off really, really suddenly. So let me grab over here. I get a spike with just a little bit of transformation. I probably should have turned all that down all the way or something like this maybe. There we go. Let's try that again. There we go. A spike with a sort of parabola-like fall off on the sides. So yeah, you can do lots of neat stuff to it. This, although it's a less precise tool, you can use this for adjusting large areas of an object, and after you've done your precision modeling, making a little bit uneven, things like that. So for instance, if I wanted to make like a sort of hand-whittled broomstick, for instance, let's just make a cylinder, and I'll make the cylinder tall with lots of divisions along the height. And you do need quite a few divisions if you want anything even remotely smooth. I'll just turn it to 50. And then I'll use my soft selection to just grab regions here. Let's turn it back to the standard. And then just tweak this left and right a little bit. Grab larger regions, smaller regions, some singular regions like that. And so I can get this more organic, natural look to this pipe now. And you'd want to do it in different directions as well to make sure that it wasn't completely flat in one direction or whatever. But this is great as a final step for making more organic, natural looking objects. And of course you can mess with the radius on the fly, however it is you'd like to do it. One thing I like to do, for instance, is to grab like the bottom row of vertexes here, then increase the size of the fall off until it just barely reaches the other side of the object, and now I can get, whoa, there we go, a spike kind of appearance where it truncates naturally along the object. Let me try that again. Or I can make it wider at the base, stretch things out. You can make things stretchy this way, and do a lot of nice big adjustments in that way. Okay, so a really fun tool and handy for more organic, non-mechanical forms. Okay. The next one I want to show is the Lattice tool. The Lattice tool is very helpful for these larger transformations of the object, but in a way that might skew the object or mess with its proportions. So I'll just use this cylinder that I just created as my base object. And you're going to find the Lattice tool inside the animation drop-down menu. In fact, we're going to use the animation drop-down menu for both this and the next set of tools, which I'll show you, the nonlinear deformers. So the animation drop-down menu, we've got this Create Deformers menu, and here we've got Lattice. I'll just go ahead and drop that on there. And you can see the lattice is like a cage around the object, and it has vertice points all its own. Now when you access these vertice points, you have to right-click and hold over the lattice to get a lattice point, not over the object to get a vertex. Okay, so make sure that you have your object on object mode. Hover over the lattice, choose lattice point, and now when I grab one of these lattice points, you're going to see, oh, I've still got soft selection on, excuse me. Tap B to turn off soft selection. You can see that as the cage deforms, the object deforms. Okay, so you can get some very interesting effects with this. Let me turn on wireframe on shaded there so you can see what's happening. The fact that the wire on the object is pink is an indication that something is driving the transformation of it right now. So just know that that is perfectly normal. So you can use this for proportional adjustment like this, or if I turn the number all the way down of subdivisions here, so I'll turn this all the way down to 2, you can just use it for simple trapezoid type shapes, or widening or thinning, squishing things, etc., etc. You should make note that just like the construction history of an object, when you have these inputs, you should never alter the inputs which are down the list. Only the final one is editable. The same thing goes for a lattice. Once you mess with the number of divisions, you really should not mess with them anymore once you've deformed something. So if I turn these up, see, it's not even going to allow me to try because I've already tweaked the shape of the lattice. Okay, so you have to put it back to its original shape before you can mess with that setting anymore. One thing to make note of is that the transformation from one section of the lattice to another is quite abrupt, so you're not going to get especially pleasing curvy shapes out of this. So let me open this way up. So what you might expect is to get a nice sweeping curve through here, but that's not what you get. You get a linear transformation from this point to this point to this bottom point down here, and you can see it's created a rather pronounced shelf-like spiky kind of hula hoop shape going through the center here. So just be aware of that you're not going to get the smoothest transformations unless you put several different divisions going through the center and carefully alter each one, or use a soft selection for that. I mean, let's see if we can get it just as an experiment. I haven't really tried this before, but I'm going to turn the T divisions up. And I'm not really sure why they use S, T, and U for this, but they're the same X, Y, Z coordinates as we're normally used to. So I'll turn this up to 12, right? And then I'll grab the lattice point to the center, turn on my soft selection again, and make sure that my fall off is about as round or about as wide as the height here. That's not going to quite. Oh, here we go. Yeah, okay, so I can get somewhat of a nice round fall off that way because it's affecting each one of the rings of the lattice separately. If I were to look close though, and I'll get rid of the lattice in a second, but if I were to look close, you can almost see the difference between one section of the lattice and the other. So it's still not a perfectly round result, okay? This would make a nice organ or something though, like a stomach or whatever. When you want to get rid of the lattice because you've made your adjustment, what you have to do is delete history on the object. If you haven't deleted history on an object before, it gets rid of all of the inputs and treats the object like a primitive. Come up to Edit, Delete by Type, History. Delete all by type will do the same thing to everything in your scene, so use that one with caution, only if you know you need it, and you have a big long list of objects, but this one will only affect the selected object in object mode. If I do that, the lattice goes away and all the inputs for this particular object go away as well. Okay, so lattices can be very helpful even for mechanical things since it does have that kind of linear fall off with them by default there. You can adjust things even if they're complicated and have a lot of detail on them. All right. Let's move on to linear deformers. I love linear deformers, and to my surprise, a lot of modelers sometimes don't know that they exist, but they can be tremendously labor-saving when it comes to shaping objects. They are in the animation section, which is maybe why some modelers don't know about them, but I find them to be very, very useful for shaping certain objects. They're located here in the animation submenu, Create Deformers, Nonlinear. And this is the list of all of them. Bend, flare, sine, squash, twist, and wave. And we can do some very interesting things with these. So we'll start with bend, and I will go ahead and make a cube which is tall and has a number of divisions going along the height. So we'll just do 30 this time. Okay. If it doesn't have these divisions when we try to bend it, it will not work properly. And actually, let's demonstrate that first. So I'm going to turn these divisions, or no, let's demonstrate it working first, since it would be confusing. So 30 divisions on this object moving vertically. Create deformers, nonlinear, bend, and it turns purple, but what you'll see if you go into wireframe view is that we've got this little handle in the middle of the object now, this little curve going down the center, and that's the actual handle for the bend deformer. With that selected, we want to go into the inputs of the handle, and we've got these channels. Now in all of these deformers, there are going to be some similar channels. Envelope or envelop is one of those similar channels. This is how much in a percent the effect is applied to the object. So it will default to 1 for 100%. If you want the effect to be diminished, then you can turn that number down to some fraction like 0.5 or 0.25. 0, nothing will happen on the object. Curvature features in several of these. If I turn curvature up, you can see that it will bend the object, okay, in a specific direction. All right. These bend handles are intended to be moved, and you can see them affecting the object differently depending on where they are. And they can also be rotated, so I can rotate them into a different orientation. That one looks kind of strange, but let me rotate it this way instead, and you can see that it will rotate the object diagonally or horizontally along the z-axis or the x-axis, wherever it happens to be aimed at the time. Okay, so you can make some fairly complicated shapes this way, so long as you've planned it to model something in a straight line and bend it as your last step. Okay, these last two channels are quite helpful, low bound and high bound. If we turn these down, the side which it's on, so low is the bottom side, turns off or shortens. So if I turn it up just a little bit, this is currently affecting this object right up till this point, and then remains straight for the rest of the transformation. So if I curve this a lot, you can see the top is bending all the way around because the high bound matched the top of the object, but the low bound, having stopped early, bends and then continues on straight. So you could make hairpin turns this way, or 180-degree bends, or however much you'd like to do. Oh, we can also scale these, by the way. And in that case, you might need to turn up low bound or high bound so that it's as large as you need it to be. So in high bound, we can turn these things up as well, but once it's past the top of the object, there's not really much point to having it longer unless you plan to scale the manipulator or move the manipulator. So for instance, I can move this down, and now you can see that it's caught up with the end of the object. And if I move it up, then less of it is affected because it's gone up through the object. So you can get some really cool looking effects with this. Okay, so that is the bend deformer. One thing to note about these is that they are committed to the object in the same way that the lattice was. If you select it and go to Edit, Delete by Type History, it will be committed. Or if you decide you don't like the effect, simply grab the handle and delete it, and your object will be back to normal without that input. Okay. It may be helpful to note at this point that we can bring up something called the outliner in order to help us see a list of all the objects in the scene. I haven't covered this yet because there's not really been a purpose, but now we're getting into more complex relationships, so it may be important. Window outliner will reveal this window, okay, with a list of all the objects in the scene. Just know that all objects start as a polycube, polysphere, polycylinder, 1, and then number themselves in increasing values from there. These 4 objects are your cameras. They're gray because they're hidden. Please don't delete them unless you want to be very confused as to recreate them. And then down at the bottom, default light set, default object set, just don't touch those for now. Okay, they're not meant to be filled with if you don't know what you're doing. But yeah, so I can leave this up and visible, or If you don't want to access it that way, Window, Outliner, you can click this button right here, which has the outliner docked on the left-hand side, and then your perspective view on the right-hand side. And so that's the one I'll probably use just so that this is clear how we can see things, but you can select things in this menu. We can also do things like parent them and delete them in this menu, rename them. So this is my test cube. Okay, we could have done that up here as well, but it just becomes a very helpful way to see the objects in our scene. So you'll see if I create a second cube, this is cube, oh now it's cube number 1 because I renamed this one, so I suppose if I get rid of one then it'll pick up where the numbering left off. But that's cube 1, that's test cube now, so we can keep track of things. But our bend handles or deformation handles will appear here as well. So if they're hard to select, like they appear right in the middle of the object and you can't quite grab them, you can use this list instead. All right, let's see what the second deformer is. So create deformer, nonlinear, flare. Okay, so there's the flare handle, and as you can see, the flare handle appears over here in the outliner as well. Opening up the inputs, we can see envelope again, so how much it's applied. Start flare, X and Z, end flare, X and Z, curve, low bound and high bound. So first I'm going to turn up curve, okay, and you can see that it makes it fatter in the middle. So this is a better way to do that effect than the lattice because it is applied smoothly, in case you want to do that. By the way, I'm dragging this farther, but it stopped at 3 there, and I can go to -3. You can usually type in a larger number for these channels, even if it won't allow you to drag interactively to that number. So it looks like, let me try 100, see if it goes there. Wow, it really did that. I'm not sure if there's an upper ceiling on that value or not, but it will allow you to type in larger numbers. See, when I tried to interactively downsize it, it didn't allow me anymore. So that's a bit annoying, but just know that that's a feature of these things. So curvature is not actually what this one does. What it actually does is allow you to flare the bottom or the top respective to each other. So I'm grabbing both X and Y so that it's widening and shrinking each side here. But we don't have to settle for just that either. Let me zero all of them out. Oh, maybe 1. These are defaulted at 1. There we go. So we don't have to settle for just that. We can do it in just one dimension. So how about just in Z? Right? So it's flaring out this way, but not in this way at that point. So you can do some fairly interesting things with that. And if I curve it as well, you know, that could make for a nice kind of decorative element. Again, we've got low bound and high bound. So if I turn down the low bound, it will move halfway through the object and then stop. Actually, that's a nice little Arabian kind of shape there, isn't it? So that would be one way to do that. And if I increase it, it will affect the object, but then affect into space out here so you can get a slightly different look on the object if you like. And high bound, of course, works the same way. Okay, so I can get a nice subtle effect that way if I move the high bound, low bound really far away from each other. It's also worth noting, by the way, that you can stack these deformers onto an object as many times as you like. If you go over maybe a rather high number, Maya will probably start to slow down and maybe eventually crash, but I haven't really experienced that myself. Just for fun, I'm going to apply a bend deformer over top of this object with the flare still applied. And so I'll curve that. And so you can see I've still got the ability to affect the flare, right? And I've got the ability to affect the bend handle. You want to remember what order you did these effects in, though, because that can have an effect on how it looks when you finally get to the end of it. But yeah, you can stack several of these on top of one object and get a very specific effect. The only way you're going to know what they do, though, is by experimentation. So I definitely recommend that you mess around with these effects, try them, see what you can get, and then use them as a problem-solving tool going forward. Now, I promised I was going to show you what happens when you don't have these edge loops going through the object and you try to bend it. So I'm going to turn it down to just that many, so just 2 in the middle here as a demonstration. So I'll create another curve because it's the, or bend rather, because it's the easiest demonstration. So there we go. It's following the bend as best as it can, but it's only got these vertices to use. Let me turn it down all the way. So selecting the object, polycube. Can I do this while it's affected? I think I can. There's with one, there's with none. Okay. So what's happened with none is that all it has is the face on the end, and there it is. The face is following the pattern, and so is that one, so nothing's wrong here. It's just that there's no information to bend, so it cannot do it. Okay? Actually, that creates kind of a pleasing effect all on its own of these kind of growing and shrieking vertical rectangles, but it's definitely not what you would have expected to happen. Okay? So be careful about that and make sure that whatever dimension you want to transform something in, it has an appropriate amount of detail in those dimensions so that you can bend it or deform it properly. Let's see what the next one is. Create deformer nonlinear sine. I think I can do this with the cube, but I'd rather do this with a plane. So let me skip that for a moment and go to squash. And I'll turn the divisions back up because I know this one will work properly for a cube. So height divisions, back up to 50. How about 30? 30 is what we did before. Okay. Then I can grab the squash handle. Squash has envelope factor expand, maxed expand position, start smoothness, end of smoothness, and low and high bound. So in this case, factor is the primary channel here. And you can see factor will push the object down and make it fatter, or stretch the object up and make it thinner. So squash and stretch. Okay. The expand, I believe, is the one that will affect how much the object becomes fat and how thin the object becomes when it stretches out. Max expand position will alter where the fatness happens, so we can alter it to be at the bottom here. So it will become thinner primarily at the bottom and fatter primarily at the bottom. So you could think of that like maybe a jumping slime creature or jelly bean or something like that. You could use this in that fashion, or just use it for sculpture, making vases and whatnot. Let's see, we've got start smoothness and end smoothness. As you can see down there, this is the bottom one. We can make the effect sweep inward sharply or sweep outward. I don't think I can use a negative number on this, but let me just try. No, it won't allow me. 0 to 1 on this particular transformation. And there we go in the top. Okay, and there's the normal. And of course we've got low and high bound here as well. Now I find I don't particularly like the way that the squash and stretch looks when it gets beyond maybe like a -1.5. So I tend to use other deformers on top of this, or maybe just do a squash and stretch another way. But it can be useful for certain things, object transformations and whatnot. But I just find that it doesn't look like a nice volume personally on this particular fall off. Okay, so there we go. And of course, if I rotate this, you can see it goes crazy. That's always fun. Squashing and stretching in other dimensions. So be careful about that. We would probably need a sphere for that to look successful. Okay, let's go ahead and get rid of this guy and create a plane for the next couple. I'm going to make the plane as large as the grid and put 50 and 50 subdivisions in both directions, so I have a nice dense grid to deal with. I'm going to go ahead and create deformer, and we'll now go back to sine. Okay, so sine, if I open up the inputs, envelope amplitude, wavelength offset drop off. Okay, so this one does some interesting things. We can see it starts vertically. Turn up amplitude, and you're going to see there is the height of the sine curve. If you've ever taken a slightly advanced mathematics just beyond geometry, you'd probably be familiar with a sine wave. It's sort of that pattern that you get from sound waves. Okay, so this is the amplitude, which is how pronounced these curves are. It's not affecting the grid yet because it needs to be going this way. for this particular object. So 90 degrees, okay? And now you can see the amplitude affects the plane. Pretty cool. Wavelength is how long it takes for this to cycle one time. So if I turn this down, we get a more frequent wave, very turbulent, spiky wave. And if I turn it up, we get a very languid, soft wave. So it would take quite a long time for this to cycle one time, even longer than the grid at this point. Now the cool thing about this is that using offset here will move the wave and cause it to animate and flap. So I like to recommend, for people who don't know how to use cloth, this is a great way to get kind of like a flapping flag or waves in an ocean or something like that. It does have a limit of 10 and -10 for dragging it, but not for animating it and not for typing in the number, so just be aware of that. Now if we did want this to be like a flapping flag, this wouldn't do because both sides are moving, and a flapping flag would have to be fixed on one end. For that, we've got this drop off here. So if I turn that up, do offset, now you can see both ends are held steady while the center is the only thing that moves. Now again, there's a slightly unflattering spike in the middle, which I'm not really sure how to get rid of, unfortunately. But we can use this in combination with moving this and the low bound, high bound to get nice results. Oh, I just turned it to -1, by the way. And that means that the center holds steady and the sides flap. So I don't know, flying book or something like that. The default is 0. So I'm going to turn the low bound off. There we go. Slide this over, slide this over to the left side of the grid. Now you'll see if I turn offset up. See, it moves, but that's all flat over there. So I'll turn the high bound up now. Okay. Try the offset now. There we go. Still swimming, still fine. And now I'll turn the offset, I think it was left that I wanted. And I've got more of a flapping flag kind of effect. So the center, or rather the edge, is completely steady. And then the opposite side is flapping as much as I want it to with whatever amplitude, with whatever frequency I want to. So I can get a nice kind of flag flapping effect from that. Okay? And of course, just like always, if I rotated this, it would move slightly differently. Okay? Or twisted it. Let's try twisting it. Like that way a little bit. So see, it's going about like that. Slightly more three-dimensional kind of look to it now. Okay? All right. Same plane with the same density and a very similar nonlinear deformer, but different because this one affects in more than one dimension. Wave at the end here. Go ahead and try that one. We get a circular handle for this one because when I turn up amplitude, see, we get a two-dimensional wave that's moving through our 3D space here. Okay. Wavelength, same thing, short, or wide. And the amplitude, same thing, how pronounced the wave is. So of course this is helpful for like droplets of water in hitting a surface. Or speaker deformation. Okay. Maybe for impact, like on somebody's fat rolls, or like a crater impact from like an asteroid hitting the ground. I don't know, something like that. This one maybe has slightly less, diverse applications, but it's definitely useful to have. Again, we've got a drop-off position, so we can drop off on the edge so that only the center is affected, or we can drop off from the center so that only the edge is affected, and it becomes peaceful in the middle. Minimum radius, so we can have no effect in the center. Okay, and a maximum radius, which is the outside edge of the thing. So you can constrain this transformation to a very, very small section, and essentially we just kind of get a pulsing ring of effect around the rest of it there. So I don't know, maybe that could be useful for sculpting a soft button or a soft plateau or something like that. So we put that down like that there. You know, there's probably some applications here that I'm not thinking about, making a trough running around on a grid like that. Okay? The last one, twist, is better demonstrated with the cube again. So I'll go create polygon primitive cube, make this rather long. There we go. And again, we're going to need some divisions here. 30 should do it. All right. Create nonlinear deformer twist. And it does what's advertised. We've got a start angle and an end angle this time. When you move the numbers there, that side twists and the other side stays put. Okay? End angle, just like that. So mostly what I've seen people use this for is twisted wrought iron or DNA strands or something like that. You can even use it for braiding rope if you actually start out with, like, to get a very realistic braided rope, 3 cylinders and then twist them all together. That's essentially what a braided rope is. Heck, let's try that just for a demonstration here. I'll go ahead and make a cylinder, and I'm going to make it really tall. Okay, let's just go, yeah, 100. And the subdivisions in the height, I'm going to need more than that. Let's go 100 there as well. Okay, now this is going to be tremendously wasteful for polygons, but I'm still going to do it just for the demonstration's sake. I'm going to duplicate this and then make a little 3 set of fibers here. Okay, and I believe this is how rope is made. I may be wrong, but I'm pretty sure that they're twisted together like this. So here's our 3 fibers. You know what? I'm actually going to turn down the width of it so that it can be a little bit thinner. So 0.5. There we go. And I'll reduplicate those other 2. Right there and right here. So you'll notice the duplicates do not have inputs because they have been taken from the original object. Only the original object has those inputs. All right, so grabbing all 3 of these, I'm going to mesh combine them so they're treated as one object. Then we'll go back into our animation menu, create nonlinear twist. Let's see if I can get that effect. Go, go, go. Okay, so it didn't want to go much farther than 900. And I didn't really get too much of a twist out of that. Let me turn off the wireframe unshaded. We're almost to Twizzler at this point. Let me see if I can type in a larger number there. How about 2,000? Getting closer. 4,000. There we go. Starting to get there, but you can see that the amount of detail on these ropes is breaking down at that point. Even though this is working, I'm getting a kind of rope look out of it. It's also best if you try to figure out what even numbers might be. So for instance, multiples of 360 would be how many twists around I had done. So let me try, instead of, what did I type in, 4,000, let me try 3,600. And I might give it a more even look. Sort of. Kind of do. It still kind of bumps in and out. That's probably because I have 3 strands instead of like 4 or something. But yeah. Okay, so there's just an example of something that you could do with the twist. And yeah, you can apply it to multiple objects, even if they aren't mesh combined. If you have them all selected at once when you apply the nonlinear deformer, it should treat them all as a unit, and deleting history on them will get rid of the handle while leaving the result. Okay, so those are all the nonlinear deformers. They are very fun to play with, so mess around with them and see what you can do. And just realize that these are tools in your modeling toolkit as well. All right. Last, I'm going to show you the Sculpt Paint tool. The Sculpt Paint tool is also rather fun. Let's go ahead and use a plane for this as well. Create polygon primitive plane as big as the grid with, sorry, there we go, 50 and 50. To activate this tool, what we have to do is just right-click and hold on the object as if we were selecting a component mode. Then go down the menu to Paint and choose Sculpt there. Okay? Sculpt will turn your cursor into a paintbrush. I'm just going to tap spacebar to open up just this window so my outliner disappears there. And it also automatically opened up my tool settings menu, which I'm going to hit Reset Tool on it just so that we're starting from the same spot. What you can see is that we get this little circle with an arrow pointing down. The circle is the diameter of the brush that we're going to use, and the arrow is how far the detail is going to move when I start clicking and dragging. Okay, so that's just a left click and drag there. Again, you can change the brush size by holding down B and left clicking and dragging left and right, just like our soft selection, or you can use this channel right here, radius U. I'm not really sure. Lower brush limit, oh, I suppose that must make it like a donut or something. No, you know, I've never been quite sure about what that does. It seems to just kind of soften the brush out, so I tend to leave that one on its defaults unless I'm messing around and finding something out. But there you can see we've got this Sculpt tool, and if you click and drag multiple times, it goes deeper and deeper and deeper, but eventually you get this kind of ugliness going on here and like, ooh, tumorous growth going on there. What's happening is that the direction it's pushing is the normal direction, as in straight perpendicular from the face as it began. So when we get slopes like these, the normal direction is now diagonal. And so if I push on those, diagonal is the direction it wants to go, and as they move more and more and more, they get more and more distorted. Okay? So these operations down here and these brush profiles help you to control this. Here we've got push, pull, smooth, relax, pinch, and erase. So I'm going to use erase to get rid of the things that I've just done to this plane to start over again. It's worthy of noting that erase will only work if you have not deselected the object. So make sure it stays selected, and erase will bring it back to the state that you began painting it in. Pull will raise upward, just like you might expect. Okay. Smooth will try to average the position of the vertices in 3D space to each other, and so it has this sort of softening effect on the mesh. Okay. Relax is similar to that, except it tries not to move things in 3D space. It tries to just adjust the vertices on the surface. Okay. Pinch will try to do the opposite of that. It will consolidate vertices together in one space. So there you can see I'm clicking and dragging over and over and over again, and these are moving closer to each other. And then finally, of course, erase, like I showed you, will get rid of the effect on the surface. Down towards the bottom here, below those options, we've got a few settings. Max displacement is how far it will push or pull. So if I turn max displacement up and use pull, one click goes a rather far distance now. I try to keep these things somewhat minimal because when you're painting or sculpting something, having a soft touch is more useful typically. And so I will either leave the number low or turn the opacity down so that when I do things, there's a very subtle effect as I sculpt them, and it's not going to be overwhelming all at once. So then I could soften that stuff out so they're no longer pinching into each other. And now we've got like some fat rolls, you know, or some rolling hills or whatever moving across this plane here. Okay. There's also a flood button. I wouldn't recommend using the flood button for push or pull, but if you use it for smooth, it's as if you stroked over the entire surface one time. So you can click that over and over and over and see the kind of softening effect spread across the entire surface. And you can also use the eraser to flood. And since I turned down the opacity now, it erased some of that effect, but not all of it. And so I'd have to click multiple times or turn the opacity all the way back up and hit flood, and then it would erase everything on this surface. Okay. There are other things worth noting about the sculpture tool. Down here in stroke, oh yeah, you can use a stylus for this, so a Wacom tablet or a Cintiq to affect the intensity of this if you want to try that out. But down here in stroke, you can do a reflection in certain dimensions. So this way is in the X direction, so when I do something on one side, it does it to the other side, which is really nice if you have maybe a creature face or body that you're sculpting on. And you can change those directions as well. So here's reflected in the Y direction. Actually, you know what? Reflected in the Y direction. Yeah, that won't work because it's going to try to pull up and down at the same time. Z direction would work, though. There we go. Okay. And also, interestingly, you can invert the reference vector. So on one side where it's going up, on the other side it's going down. And that can be really fun way to work as well. For instance, if you wanted on the sides of like a sphere, a bulge on one side and a dent on the other, so that the detail goes in a singular direction, you could do that. So let's do that real quick. I'll go ahead and tip this over on its side, 90 degrees. Let's make it bigger so I don't have to change my brush size as much. And I'll increase the detail. So right click and hold, paint, sculpt. Now I've got the reflection and an inverted reference vector, so I'll make a bulge on this side. And we should have gotten a hole on this side. Yeah, there we go. So the detail is moving straight through the object like that. But as you can see, I could also paint like a face on here. So let's just go ahead and do that on the sides here. I'm going to turn that back off. Oh, the reference vector is a little bit messed up now because I've got sculptural detail, but it should still be fine. I'm going to turn down the size a little bit and do a couple eyes. Jeez, it's getting really messed up, but oh well. And a little face. Yeah, basically, okay? So there you go. It's also worthy to note that this sculpture tool in Maya is kind of used for overall detailing. I would not use this for fine surface details like putting pores on a face or individual muscle fibers like on a body. There are other programs which do that better and more efficiently that can be used in conjunction with Maya, such as Mudbox or ZBrush. Or what is the other one? 3D Coat, which I tried out and rather liked. So those are all different softwares that you can use for fine sculptural detail. This is really more used for wide polygonal modeling detail. Okay? So your homework this week is going to be to make some food. And by food I mean produce like vegetables, fruits, or you could also make slices of meat. Cheese would be good. I want organic shape. So if by food you interpret that as like a soft drink in the paper cup and a burger inside its wrapper, that's no good. Okay, I want organic food, organic matter. Okay, you can also try to do flour if you would like to, but I would like at least 2 objects. Okay, so 2 organic objects. And when you guys see me in class, be sure to request that I demonstrate how to make an apple or a banana or both, because I have some established methods for making those which are rather successful, but that's the type of thing I'm going to be looking at. Okay, so minimum 2 organic food objects which have nice uneven surface characteristics that will stretch you in using these techniques. All right, I'll see you guys next time and see you in class.